Thanks everyone for taking the time to come to the talk. I know it's something of a captive audience given the state of the world is right now, but again, hope we can make this interactive. This is purely just about my experiences, going into a regulated environment, not for the first time, but for the first time where we had to get to a point where we used a tool like Kubernetes operators. And again, what I hope to kind of just get across here is kind of the thought process and where I had to fill in the gaps from a learning point of view. And like I said, please ask as many questions as you want. There's some things in here which will be obvious that are maybe not covered, but again, it's a pretty broad topic. But anyway, I'll stop slobbering and carry on. Hopefully you can see a walkthrough slide here. I'll talk about what the actual business problem is that we're trying to solve. I mean, if we're not solving a problem, then really we're just having a bit of crack, really, aren't we? So I want to make sure we understand what the problem is we were trying to solve. Talk a bit about what operators are, and again, I'm going to assume some Kubernetes knowledge in the room here, so I'm not going to go into anything around what Kubernetes is. I want to go into a bit about what operators are. I'll talk a bit about what the alternatives are and why we discounted those alternatives, and the thought process around basically, please don't make me write an operator, and up to the point where we had to do that. And what I did for deploying and testing, some of the gotchas I come up against, things which you didn't flat out think of, which should have been obvious up front. And then just some final notes on monitoring, logging, et cetera, et cetera. I hope this is a full list of acronyms. I hope that I don't imagine that anyone's too kind of unfamiliar with most of these. I will be talking a bit about the various public clouds, not so much about on-prem, but again, for context, this is something that we did in a multi-cloud deployment. So let's define the problem. The problem at a technical level is that Kubernetes, even though it's been around for what, five, 6 years at this stage, it's still safe to say that there's a certain reticence to running stateful workloads on it. And I will say, granted, there are plenty of topics out there, plenty of material out there on how, for example, you might run a database like Postgres or MySQL. And actually MySQL has one of the as a pretty cool operator for Kubernetes, which just gives us a reference. But there is still a certain reticence to running stateful workloads on Kubernetes, and I was kind of interested as to why, and that was one of the questions I asked before I set off down this path. And maybe this does bias the conversation a little, but I hope by the end of this you'll kind of see that our decision process was somewhat rational. Hopefully we're looking at defining the problem slide here, and Google Slides isn't being a bit difficult, but what we were doing was we were working with Google to make a POC fit for production for a large US bank. And of course, the instant anyone says bank, we know that that is a very overloaded term. Let me just check I haven't missed a slide. And it was a multi-tenant application. It was targeted as being a multi-tenant application, multi-cloud, which was initially private cloud and Google Cloud, but has since morphed into AWS as well. There was an existing application in which the POC was based. It was an on-prem application, and the issue there was it took days to provision new tenants. I do think I have a slide after this that goes into a little bit more detail. And it was, classic old problem, limited by physical capacity. Sooner or later, an accountant takes notice and wonders why you're buying all this equipment. And what we got when we started this engagement was what it can only be described as kind of a big mash of YAML and code and already existing containers to make sense of all this. I'm going to talk a bit about what this application is in a second. Other than to say it was an application which has, it's multi-node. Initially it was 7, but we needed the ability to scale to hundreds and thousands. And I'm going to use the word node and tenant interchangeably here, so apologies for that. And ultimately, the tenants need to know about each other, but each of them have their own secrets. And typically, those secrets came in two categories: an application-specific key, and good old PKI in the form of public and private keys. And I'll talk a bit about how they factor into things in a second. So try not to cringe, but this was a blockchain application. Whoops. And what was unique about it? Well, maybe not unique, you know, in a sense, because this is pretty common, I think, with you know, current state of the world in blockchain. The kind of blockchain that we were working with was the kind on the right. So rather than being a public blockchain like Ethereum, et cetera, this was a private blockchain. And the idea behind a private blockchain is that it fundamentally works like a blockchain, but you have the ability to do two things. Number one is to decide which nodes can connect to the network, who can peer to the network. And secondly, the ability to conduct a private transaction over the blockchain. Now, what does that mean? That means that you could have two institutions, let's say two banks, or it could be two anything really, who want to conduct some kind of a business transaction. But they don't want the details of that business transaction to be visible to other members of the network, but they want the network to see that they have both validated this transaction. And I think that is, I'm not going to get into any more about blockchain, because again, we're not talking about blockchain specifically, it's more the application. So those were the two main features of this POC that we need to talk about. And of course, that's where the node-specific secrets and PKI started to come in, which I'll touch on in a minute. So again, apologies. This is the last time I promise I'm going to talk about blockchain on any level of detail. Look upon it more as a case of how you handle, how you handle a stateful, a multi-tenant, well, sorry, that's an overloaded term. Well, maybe not so much. A stateful, multi-cloud, multi-tenant application in Kubernetes, and more specifically where operators come into play. So at the core of the business problem was, like I said briefly, that the initial POC was built out in a private data center. They'd literally bought enough equipment for 100 tenants, and that was it. Needed to scale out to many hundreds of thousands of, or even thousands of those tenants. And before we did the work there, really adding a new tenant on-prem took days. They literally were unboxing equipment, racking it, and networking. So when you were trying to onboard customers to this platform, in this day and age was kind of a bit medieval, to say the least. And again, be able to potentially support multi-cloud environments in the future. But the last bullet, and probably the one that's the thorniest, is it must be able to connect to an on-prem environment. And I'll talk a bit about why that's a particularly sticky issue in regulated environments. So let's take a look at the basic application. I know we're going from 10,000 foot down to 10 foot, so to speak, but this is literally an approximation of what we got when we first started working on this. So we got a project with a makefile that started up Minikube. Minikube is a tool you can use to run a Kubernetes cluster on your laptop. I have like a 32 gig i9 MacBook, and if you spin up enough containers, it will grind it to dust, but that's another story. And let's talk broadly about what it is. It had one namespace where all of these different tenants, remember a tenant maps to think of it as a specific institution or bank, and they had modeled it as one pod per bank. But all in the same namespace, with nothing like network policy or any kind of pod security policy governing any of this. And again, this was a POC, so that was to be expected. The application itself consists of two main containers. One container which ran the core blockchain application, and one which was a transaction manager. And the transaction manager is the component that enables those private transactions that I referred to earlier. So even though it's not described on here, that transaction manager has secrets which are keyed to that institution. And when we got all the config from the customer, they had public and private keys in clear text in the YAML. And again, it's not I'm not denigrating the user in this case. They were doing a POC, but of course that was one of the things that fundamentally secrets in the clear is a solved problem in Kubernetes, so to speak. So again, there was a lot of low-hanging fruit here. But this basic model here of scaling this out from there's 4 on screen here to hundreds, while adopting good practice with regards to how we handle identity and how we handle secrets was absolutely key. And there were, this wasn't just a core blockchain just for the sake of it. We had, there was a lot of applications built on top of this as well, which, were not, we weren't, it was not for trading coins. It wasn't that. It was, things like custody transfers and KYC kinds of applications. Basically, stuff that blockchain enthusiasts tell you blockchain's really good for, but for most of us kind of maybe raise an eyebrow and say, yeah, you could have done that kind of easier. But that's another discussion. So again, in summary, this was literally all running on a laptop, as it is in front of you, and that's what our starting point was. So, so let's get on to I'm going to pause there just for a second and see if anyone has any questions or anything they want clarity on before I carry on. Again, feel free to interrupt me as I'm going on. And all right, so this really is a summary of kind of my own experiences working in regulated environments. And in a previous life, I led security engineering at a bank, at a globally significant bank. One of the banks that was deemed too big to fail. And with that kind of guarantee of infinite taxpayers' money came with it a lot of restrictions, and specifically a lot of restrictions and compliance mandates around data and IT, and every little minutiae of any platform that the bank used. And this is very similar to the project I'm working about right now. But the two common things which always come up, I find, when working in these environments, are identity and encryption. When I've went through security audits and the likes for some of the platforms I worked on previously, I could spend an entire week working with an InfoSec team purely talking about identity and encryption. I think that's something we can all appreciate. But they need to be, at a point where any given API call, any given operation, any given workload can be connected back to an identity, and that identity mapped back to an end user of some kind. Again, on the face of it, that sounds like standard security practice, and I think in this day and age it should be, if it isn't. But I think we all know that the reality tends to be far different from the aspiration. And I think the second thing, which is fair to say, is I think public cloud is still a relatively new concept when it comes to these regulated environments. And it's not that they don't understand what public cloud is; they certainly do. What's not understood is how to move workloads into public cloud while satisfying the various compliance and regulatory mandates that they have. And those could be anything based around data privacy, from data privacy just through to plain old, corporate security standards, that you're going to find in any bank. And I think that's kind of another bullet, which I probably wouldn't, I haven't specifically called out here, I believe. But if you think of the standard security practice in cloud native environments, it's a zero trust model. It's a model where again, as the title suggests, no one component trusts anything else, and what follows on from that is the principle of least privilege. So the idea of having multiple ports open on a server, for example, or multiple user accounts belonging to on a server when they're not needed is an alien concept in the cloud native world. I'm sure that John could talk about Sysdig's perspective on that until the cows come home. But again, these are relatively well understood concepts in cloud native architectures, but they don't really translate well to that. I'm going to say old school way of thinking of perimeter based security. And I think, again, we don't need to get huge detail on that, but that's and I spent years at IBM working on these kinds of platforms, and it's that idea that if you build a big enough wall, well, if you find a new vulnerability or a new breach, you just need to build that wall higher. Whereas in fact, I think that the sensible perspective is to assume that breach first mentality, and that I've already been breached and I'm just trying to reduce the blast radius of any given compromise. And again, this, I think this is the third time I've went through this particular discussion with an InfoSec team. And again, all of this comes back to, you might be wondering, what the heck does this have to do with operators? Well, an operator is like any other component. It handles data. We have to be careful of what it connects to. And I'll talk a bit more about that in the ensuing slides. But just keep that in the back of your mind. You have this old world view of looking at security in regulated environments, which is very perimeter based, and this new world of looking at security in the Kubernetes world, where we have that zero trust, breach first principle of least privilege mentality. And again, I think I covered that in the third bullet point somewhat. But again, another finding I have is that especially given some of the people or companies I'm working with right now, they run their public cloud like they run their on-prem data center. They're very strict about things like IP address, and they have processes which are, the classical fill in an Excel spreadsheet, send it to me, and 2 weeks later you get a VM. And back to a bullet I talked about earlier, and remember I talked about that requirement to connect this new environment onto an on-prem data center. That again, I think it's my third time trying to talk to or trying to get an InfoSec sign off and connecting a public cloud workload to on-prem in a regulated environment. This is an absolute bureaucratic nightmare. I guess more of an observation. It's maybe not so much to do with how you build an operator, but again, I'm just trying to set the scene here for what it was we were doing. Needless to say, there's no external connectivity. There's nobody doing a Docker pull from Docker Hub. And there's a big focus on that secure software supply chain, and that also rolls over into how you build and deploy an operator. And I will say that, I think one of the things that all of us who, I'm sure all of us in the call appreciate, is that the shared security model, which the public cloud vendors talk to, it's only a good thing for us as DevOps people. It means we can concentrate more on addressing things which are important to the business, rather than bootstrapping servers and racking equipment and and mucking about with Cisco switches and the likes. And when you present something like this to a customer, where on the left-hand side, this is a more traditional stack where, let's say, they're running VMware on-prem, the customer is ultimately responsible for every part of that stack, from networking up to the applications themselves. And again, I talk to security here because, again, in the regulated environment, that's the first thing that is going to come up. It's not necessarily operational agility. It's, are you allowed to run this in the first place? And when you show this, when I showed this, this is more of an anecdote, but I was in a room with a customer, and Google were down one side of the room, and the customer was down the other side of the room, and we were in the middle pitching the architecture. And we showed something that resembled this slide. It's a powerful enough story. Over on the right-hand side, you have Google, basically, or AWS or Azure, for that matter, owning the data center, worrying about security, worrying about physical access, and all those things that we have to worry about as security practitioners and DevOps practitioners. The only thing you have to worry about is building your application, those two things out of versus the 7 things on the other side. And remember distinctly, those of you who are familiar with VTPM, which is Google's hardware-based security module for their for GCE. And this is a technology which is designed to prevent tampering with nodes at the BIOS level. And I distinctly remember the customer asking for a full pen test on those VTPM modules. Again, this is a very old school, very old school perimeter-based mindset. I find it's selling this shared security model and getting them to adopt it is a difficult concept. But again, maybe I'm gonna I'm going to come back from my tangent right now, but again, setting the scene for the environment into which we're running. I'll pause for a second and take a drink, and leave it up for questions. And just to be clear, it was GCP that this initial project was rolled out to. And I'm going to say this: these are the challenge. After the experience now, I've kind of been through this 3 times. My advice to you is to always challenge, if not overtly challenge these assumptions, it's at least ask yourself, you know, are these things true? And what especially we find is that, you know, when the customer came to us with this application, said, you know, this is running on Kubernetes. We want to run this now on GK and scaled up to thousands of nodes. The first question we asked, well, is this workload suitable for Kubernetes in the first place? Because frankly, it wasn't and isn't, at least yet, without some more work being done. And that's the first important question, because I think any of us that have worked with Kubernetes know when you run this thing in production, you know, especially upstream, thankfully we didn't have to do it in this case, but it's a complex, it is a complex beast. And I almost see this, this equation in developers' heads where they think that maybe Kubernetes is just an evolution of J2EE, which I think all of us would wince at the idea and know that that's just not the case. I think the third point is you know, again, is that just throwing logs at something like Splunk or QRadar or ArcSight is really not going to do anything. And it's not going to do anything to help, you know, you from an application monitoring point of view, or you know, a logging point of view, or trying to get to any kind of incident resolution. I'm sure this is something that John has a good sales pitch around. Let alone the fact that, you know, in theory, a pod could change IP addresses, you know, multiple times a day, and you know, trying to handle that on a platform like QRadar or Splunk without that kind of background knowledge, the nature of the application, presents some real challenges. And again, back to the old mindset, of you know, of perimeter-based focus. The same thing happens every time. We get given an IP range and said, you know, all of your traffic's going to egress through this CIDR range, and that's what we're going to monitor. And to which I'm, you know, all of us are kind of saying, well, what are you monitoring? What do you know what to look for? Do you know what east-west? Do you know what a container breach looks like? Do you know what happens when an operator fails, or how to spot that kind of pattern in logs? You know, and again, challenging that assumption that the security teams know how to secure and monitor container-based workloads. And lastly, you know, connecting to external services, or even services in another cluster or another internal API, is necessarily something which is a menial task. Again, I've waited 4 weeks and again, I'm sure everyone on the call has a similar story. Waiting weeks for a port to be opened, and then for it to be opened and told, oh, this port's open, and then you realize, no, it's not, you opened it in the wrong direction, or something daft like that. That's what I'm really saying is, all of what I'm trying to get to is, I did everything I could to challenge the customer on, well, do you want to roll out Kubernetes, given its complexity, and given that, and given the nature of your workload, which is highly stateful, which calls for an operator, is this still something you actually want to do? And no, well, how do I articulate this better? Well, I'll carry on through the slides to give you some more context. But just a few footnotes here on, you know, on what, again, this is something we work closely with Google on, and I find the fascinating thing about Google is if you ask 10 Googlers the same question, you'll get the same answer 10 times. And this is kind of right from the GCP playbook when it comes to securing a GKA cluster. And again, relevant because that's ultimately what we're building an operator for. You know, GKA is this concept of a private cluster configuration, which is exactly what it sounds like. There's no external access. However, I believe it's still in beta in the Terraform GCP module, which is what we use to build all of this infrastructure. Standard practice now is to adopt gvisor, which is the container runtime, the sandbox container runtime that Google open sourced recently. shielded VMs, which use that VTPM capability, which I talked to basically provision your node pools. And again, all these things are covered in the Google Cloud beta modules, as opposed to the release versions. Excuse me. And to give you some background as well, you know, in my current position and a couple of previous positions, I'd worked with Google on their standards for deploying workloads into regulated environments. And the question of what constituted enough security with a view to multi-tenancy is a question which I don't think has still been sufficiently resolved. Broadly, we divided it into two main categories. If we want to do soft multi-tenancy, and we mean really soft multi-tenancy, then things like namespaces, network security policies, you know, pod security policies are the go-to for that. But when it comes to hard multi-tenancy, I don't think there's a good story for that inside Kubernetes, and you end up going to the actual your chosen managed service. So in the case of GKE, for example, you know, things like shielded VMs, gvisor, of course, but then also looking at provisioning multiple node pools and using pod affinity or anti-affinity to ensure that workloads were isolated from each other. But again, this is where you go back to the customer and say, if I'm just building a node pool and scheduling nodes which are only ever going to run on a specific node pool, are we really starting to get to the point where Kubernetes is just getting in the way of you building your application, because you're basically treating your containers and your container-based workloads like VMs in effect? I don't know the answer to that. I just thought it was an interesting thing to kind of to talk about, and I'd be really interested to know if anyone has a strong opinion on various kinds of multi-tenancy in Kubernetes. And this is, by the way, John, this isn't a nod to you. This is actually what we ended up going with. Again, just a visual representation of what it means to, you know, deploy gvisor. You know, where each container is sandboxed. We also had an enclave in place for managing secrets, and we made heavy use of the vulnerability scanning beta in Google Cloud for doing basic vulnerability management on containers. So while we still relied on gvisor and sandbox, we still deployed a container runtime security tool in the form of Falco, because we were too cheap at the time to buy enterprise. But again, back to the point. It's one thing to deploy something like Falco, but getting a security team who knows how to tune it or know what to look for is another matter entirely. Moving on. Okay, before I get to the operators part, I'm going to pause and ask for I'll leave it open for any questions.
Just that last slide you had up, I presume those were just scanners happening on containers as they pass through your pipeline into production, as opposed to live scanners. So the vulnerability scanner is just scanning images in use as opposed to active containers, if that makes sense.
It's in the case of GKE, we were pushing the artifacts into GCR, Google Container Registry, and it's a feature we just turned on in the console, and which literally scanned them before we deployed them. But that's where things like System come in, when we actually want to do real-time, you know, real-time vulnerability management in effect. I'd used Twistlock at previous company, using Falco at the minute where I can. But I think I have to buy Sysdig Secure in order to get all of the cool runtime stuff. But again, these are, to this point, this is one of these moving a mindset, at least initially, with a team from, you know, a vulnerability scan is basically where you start off Nmap or Nexpose or Qualys, and you give it an IP range and a set of credentials. You know, there's still that inertia or momentum in that regulated environment to support that kind of workflow. But that's where things like Sysdig, the paid for version, and Twistlock come in, where they can do that kind of real-time vulnerability management. And I say real-time vulnerability management, again, that's a different process. That could well be, you know, jailing a misbehaving container. It could be, you know, adding rules to lock it down automatically. It could be basically, preventing any traffic from getting to it while we figure out if there's a problem with it. Again, in that kind of regulated environment, I've yet to come across a team that can do that out of the box. It's very much translating those processes to old school concepts. Vulnerability management, well, I'm not going to give you a side range, but I will give you a report which we generate every day by running a sysdig query, for example, that tells you what's running in production right now.
Okay.
Again, a beta feature, which doesn't fill your customer with confidence when half the stuff you're using to support a secure environment is in beta. But again, I find that the beta to Google basically seems to mean production ready.
Just on that, was there a build time component? Because now you're breaking out into distributed security, you're looking at application security as well. So were things like, were concerns that you would observe in traditional runtime, like was it possible to move people backwards and say, well, there's a whole bunch of best practice in Docker you can do to limit any of this stuff even getting into this? Right,
and I kind of skipped over that part because again, the secure software supply chain was a big part of this as well. And certainly building a Docker base image and having, and in fact, the customer themselves, while not, kind of completely au fait with running workloads in cloud native environments, at least had the tooling in the form of, Qualys especially has some really good extensions for handling, container security and setting sensible defaults for Docker. So yeah, there's definitely a crossover there, but when it comes to the runtime itself, that's where I find the challenges are.
Cheers.
All right, operators. Again, I'm not going into a huge amount of detail. I'm just going to try and stick to the facts that I need to tell this story. What's an operator? An operator is basically for managing stateful applications that require, and that's my interpretation, but it requires some kind of dynamic configuration. And again, just to be clear, I've worked for Puppet in the past. I was a big Puppet user. I'm a big fan of Ansible and Chef. Those are tools I kind of would lean on a day-to-day basis. And so I'm not one of these kind of people who like to solutionize and say, oh, there are operators, they look cool. I'd really like to write some Go. I'll go look at them. I'm looking at, again, what it actually did first. And I have a comparison slide, which will hopefully give you some insight as to what, why we went that way. The idea behind the operator is, and again, it's overloaded to think of a human being in this case. It's really to automate and codify, a non-trivial management process for running a stateful application. So, bringing nodes up, putting them out of commission, doing backups, bringing them back up, having them resync with a cluster, all those things which, from my first ever job was as an Oracle DBA, all the things I used to do manually to manage the database. The idea of an operator is that's the codified version of that. So very much like you might consider just writing your Chef cookbook or your Ansible playbook or your Bolt manifest. The same idea, but an idiomatic way to do it from within Kubernetes. It's been available since 1.7. Don't ask me when that was released. 2014, 2015. But it's really just another controller with some additional semantics around it. And again, to hit on the point, the operator was interesting to us because the actual blockchain application we talked about had a very specific workflow and a lot of failure states which had to be kind of accounted for in order to make this worthwhile. Again, what we were doing was giving the customer the ability to provision everything from a small cluster of 3 nodes up to a cluster of 1,000 of those tenants or nodes in a Kubernetes cluster. And this is just a slide of some of the, the thought, or an approximation of some of the discussion we had. Operators allow the management of applications inside Kubernetes with native idioms. It works with the API server. It works purely with the same constructs that you work with as a, if you're using kubectl at the command line. It's got a lot of flexibility. If you actually write the operator using Go, I mean, Go of course is a first-class programming language, so really the sky's the limit, and there's no sandboxing that goes on outside of it running inside a container, of course, that prevents you from using any features, any APIs. You can basically be as crazy as you like. I will say it requires more programming than I would really like to have to do as somebody if I'm putting my DevOps hat on. You know, it's very much back to my previous lives of a software engineer. There really isn't a massive body of work out there to rely on, so it's not like you can, you know, it's not like finding a JavaScript framework du jour and finding a rake of documentation on Stack Overflow. I mean, I mentioned the MySQL operator, I think is a really good example. In fact, the memcache operator is probably the most idiomatic version of an operator, which you could go and look at as something to use as a reference. And lastly, I didn't finish the bullet, sorry, but what I meant to say was of course it's sensitive to changes in the API. So if you find yourself upgrading between 1.14 and 1.16, as I did, certain APIs had moved from beta to V1, and my operator broke. What can I say? I'll talk a bit about testing at the end of this. So versus other things, well, what about stateful sets? Stateful sets seem to be the perfect, you know, technology to kind of use here. Well, to an extent, but what's missing really, and the key thing that the operator does for us that something like a stateful set didn't, was the application level configuration. So whereas I could pin a pod or a container to a particular volume or persistent volume claim, I couldn't, there was no really easy way, or at least obviously easy way to do that with stateful sets. And I cover the workflow in a couple of slides time. For Helm, again, Helm is another option, but with some ability to inject settings into the Helm chart. But again, very kind of more difficult to do things dynamically. And, you know, especially where you need to know what else is in your deployment in order to make decisions based on that. And again, Ansible Chef Puppet would be kind of a safe go-to, but I think, you know, it's really non-idiomatic with respect to containers. Of course, you could use Ansible Chef or Puppet to run deploys or pull information from the API server. But when you work, you know, back to the point we're working in a regulated environment, if I'm in a position where I need to lock down a port on the transaction manager, for example, to say, I only want to accept traffic from within, you know, from within my namespace or from within my cluster, the idea of having to open that service to an external entity like a Chef server or a Puppet master just to do some provisioning, well, I've instantly broken, you know, my security story or made it much weaker. And again, you know, I found that working with, you know, InfoSec teams, especially in a GCP environment, they will question absolutely everything. I realize there might be a bit more discussion here, and I'm interested in it, and I'm interested in kind of what might be the gut reaction of people with faced with a similar business problem or technology problem to solve. But again, feel free to jump in, but we can have a chat at the end if that suits better. So the operator lifecycle, I'll show you a bit of code just to give you an idea of so you can actually see I'm not just bullcrapping you. But it's basically like this. Custom resource, by the way, in this case just means that's basically that's the thing I want to deploy. In this case, it's a new blockchain node. And really the lifecycle is, well, first off, is it valid? And if it is valid, basically checking if the resource is currently initialized, i.e. doesn't exist. And that literally means making an API call to check if, you know, if a particular object exists or there's a running pod or a container or a service or a volume claim for that matter. And it's purely up to you as a developer to do all of the things that you need to determine if this API request to create a new node is valid. Another example would be if you had a setting that said I now want 3 pods instead of 2. The fact that you're letting the operator handle this means that it's up to you as the developer to correctly scale the number of nodes, for example, so it's not something which is handled for you. The other case, of course, is my resource being deleted, you know, that in the context of an operator, I mean, that's kind of self-explanatory, isn't it? I've just deployed something and I want to delete it. Surely that's you know, a relatively simple thing to do with any given framework. Little nuance to it, which I'll cover when I'm going through the code. But you know, and if all of those things are true, if it's valid, if it's initialized, you know, and if it's not been deleted, then that thing in the top right-hand corner, manage operator logic, that's what I'm interested in. That's where I do all of the custom application stuff that I have to do to wire these blockchain nodes together. And that's on that little green box in the top right-hand corner is why I ultimately went with an operator. But again, let's dive into a bit more detail. So, and again, back to what I was saying, I did everything I could to not have to write an operator. You know, I'm lazy by default, so if I can get away with not doing things, then I'll not do them. And again, trying to rely on standard tools that are out there, I think is, I mean, you know, it's a safe approach, let's face it. And what we did initially is exactly that. We went to the customer and said, listen, this is not suitable for a Kubernetes cluster. You know, you already have an application which will quite easily run on a VM. And the nature of the application, which didn't lend itself to auto-scaling. So for example, if I had you know, a pod that represented a bank or an institution, having 3 versions or 3 copies or 3 replicas of that pod doesn't actually do much for you in the context of a blockchain, because the blockchain itself is what's the correct terminology I'm looking for here? It's not primarily sensitive to, you know, network latency or, you know, or CPU bound necessarily. Certainly there's limits to that, but basically scaling up 10 pods for a bank, for example, does nothing for me. And the nature of the application itself is that each institution is bound to a static IP. So obviously in the Kubernetes world where pods can be rescheduled, et cetera, having something flap IPs fundamentally breaks the blockchain. Now, I think that since I performed this work, that problem has been changed, but let's just say and summarize that running this in VMs fulfilled all the requirements for the customer. We could scale, we could just provision a new VM every time we wanted to you know, add a new node. It would take 20 minutes. We could rebalance the network, invoke the APIs, do everything, and you know, from your point of view as an end user, you don't need to care that it's running in a cluster. You know, and because you know our go-to tools are Terraform, Ansible, and Packer, things we know and love. Chef's not on there. We used Chef to build the base images for each of those compute engine nodes. And again, the InfoSec team loved it. They know how to do that. They know how to you know, bless images. They know what the vulnerability management process looks like for that. So literally, we said to the customer, we implemented this first. This is what you need. But again, for reasons that you know, that we kind of resisted, you know, initially, customer had us go on and do the full Kubernetes-based approach. And again, if this is a very basic diagram which belies a lot of detail. This part here, cloud connectivity to the on-prem data center, that took months. It took months. And the reason is, I mean, and it's perfectly understandable, where you have 2 environments, one of which is owned by, you know, both of which are owned by different companies. In a regulated environment, opening up your network to an external entity is a big deal. And that resulted in a full-on security audit. I completed, you know, NIST SP83 framework for all of this stuff, you know, which took months and months. Again, not fun, but like I said, you know, I think the important thing I'm trying to get forward here again is, what is it we could do to fulfill the business need and not have to go to something like necessarily like Kubernetes or operators for that matter, which are definitely more on the bleeding edge. So that was what we did initially. You you know, and I think that one of the things that we what we ended up doing was this hybrid approach where, or this was the next evolution where we ran the applications themselves. And I don't mean the blockchain application, the core blockchain was still running on VMs, but we had the actual applications themselves running in the Kubernetes cluster, which they had up and running, which they knew how to deal with, you know, because they're relatively benign applications, which were by and large stateless. But again, back to the old the thing I'm going to keep talking about, running stateful applications on K8s was a challenge. It's probably the wrong, apologies, this is probably actually the wrong graphic for this, but I will say this, but the only time I've talked about identity, another key thing back to what I was saying was, you know, for each of those nodes, being able to tie those back to a service account, which in turn can be bound back to an identity, was a core requirement, and is a core requirement in any regulated environment. You know, and service accounts are an easy enough concept, but you know, the hidden complexity here is how you bind that back to things like the kubectl command line using OADC. It's binding it back to a no-auth provider, something like Keycloak is what we went with initially, but then ultimately back to the entitlements platform in your institution of choice, where there's a whole onboarding process with just getting access to stuff. And again, alternatives to operators, well, start off not Kubernetes. Secondly, not operators either. And again, this is maybe more of an internal monologue, and I'm definitely interested in a chat at the end about what people's findings are. But after working with K8 since 1.6, I find it harder and harder to justify just having a default position of, well, run it in Kubernetes. Because the fact is that, you know, especially the config management tools like Terraform, Ansible, Chef, Puppet are really good at scaling applications, you know, by and large. Of course, they have a learning curve with them, but, you know, again, established tools, a lot of user base behind them. Tools like Nomad, which arguably are, you know, a stripped down version of a container runtime. Some experience with Nomad, some experience with using Console as a service mesh. Again, the fact that you can get your service mesh and your container runtime from the same company, and both of which are open source, again, is a pretty compelling proposition. And it also avoids having to go that Istio route for those of you deploying service meshes. And again, Istio is another one of those things I find that a customer thinks they want Istio, but don't really understand the ins and outs of how to deploy and manage that kind of a technology. I'm not saying I do either, by the way. I think it's safe to say it's sufficiently complex technology that moving to Kubernetes in the first place is something not to be taken lightly. But secondly, deploying Istio on top of that, I mean, that's quite a big move. Like I said, initial version was based in Chef and Ansible, and we fulfilled the requirements of the problem. We could deploy 100 nodes in around 20 minutes. I think I timed 100 nodes on both Kubernetes and VM-based approach at like 25 minutes, and most of that was Kubernetes actually just provisioning the underlying or scaling the underlying node pools. Apologies for that. Oops. Sorry. So let's talk about designing the operator. So what do we need this operator to do? We needed it to provision a new node. We needed the ability to take a node out of service and then back up that node before potentially doing an upgrade or just as part of a regular backup cadence. Again, strange to have to be doing this with this kind of application, but again, a requirement unique to this application. We want to be able to remove a blockchain node. Now, you know, of course, people who understand Raft and the likes are going to say, well, Raft does that already. Well, again, we found that if you didn't cleanly remove peers from a permissioned network, you started to get into all kinds of funny problems. This is kind of obvious to anybody who runs in K8s, but handling pod evictions and what that does to your network. So again, when you evict a pod, it may not come up again with the same IP. And right now people are wondering, like, it's like, why did you go the Kubernetes route with all of these difficulties with the nature of the platform? And again, I'm saying, and hopefully what I've demonstrated so far is that that's the exact question I asked, or we asked. We need the ability to restart or protect nodes. So if an overzealous admin, you know, removes a pod accidentally, that the operator is able to detect that, start it up, and rebalance the network. And lastly, but by no means least, a zero touch for secrets and credentials. So remember back when I said that, you know, when they sent us all of the YAML, they had what should have been, you know, protected secrets in clear text. That's really what I'm getting at there. So in the case of the permission blockchain, there's an artifact called a node key, which has to be generated and is unique per node. If you have that node key, you have the ability to peer yourself into the network, which is, of course, something we want to be careful about. In the case of PKI, that's how we actually encrypt blocks between each of the nodes, is using a private key. So relatively straightforward. And I've lost my, oh, there we go. So this is the workflow. And there won't be a test in this, but I kind of just really wanted to point out what we needed to do and why things like stateful sets and why things like Ansible could, or Chef or Puppet would have been a poor choice. Well, the first thing we needed to do was generate unique node credentials. Now we could do that outside the operator, yes. But, and again, we actually retained our Ansible code for actually generating those credentials. We need to generate a public and private key. The key thing was allocating an IP address for the new bank, because remember, this blockchain, due to one or more issues, needed a static IP, and if that IP changed, you needed to remove and add the node again. But the nature of the application was that in order to add a peer to into the network, you had to know the IP address beforehand. Now, if I brought up a pod, well then obviously I could get the IP address just by querying the API server, but I needed a node ID from the master node to feed back into that pairing process. So it was I'm confusing the matter, but it was a catch-22. You know, and that's why it was easy in VMs, because we had, you know, we could use static addressing and use sequential IPs. But in the case of Kubernetes, well, we can do it with pod annotations. Again, a bit more difficult. We needed to use that allocated IP address and the generated node ID, which again is generated by calling the master node with the IP address you haven't yet created. But again, we got around that using a service, or provisioning the service for the pod. You have to wait for the node to appear in the network node pool, and then in this case, the network node pool is the blockchain peer list. It's not a node pool in the Kubernetes sense. So there's a wait logic that has to be put in there. We have to invoke a pairing function on the transaction manager. So we have 2 API calls so far to add this node in. Again, passing the allocated IP address on our existing node, and then we have to wait for everything to synchronize. And then, as a matter of a smoke test, we ran a test private and public transaction. Again, public transaction is something you get by default with Ethereum and all those other blockchains. A private transaction is something which, if you set up your PKI wrong, is immediately apparent. And this is ultimately what we had to deploy. And this is really what our initial effort, our initial target state was. Now, a concept I'm going to introduce here, which I haven't really touched on before, is that of the custom resource definition. Now, any of you that have written Kubernetes YAML know that, you know, we have those top level objects like deployment, like pod, like volume. What we did for this effort was to introduce a new API object, and that's what the custom resource definition comes from. Again, I talked about that in the second glossary slide. So what we're basically doing is we're giving the user a construct that says, I want to deal with a representation of the blockchain node or of that customer or of that user. I don't want to have to, you know, deploy a service, deploy a pod, maybe wrap it up in a deployment. I don't want to have to provision my volume or worry about creating secrets or config maps. I want that quorum set over here, this object here, to represent everything I need. And I have a slide in a couple of slides time. And that quorum set, which is just a chunky YAML, is what my quorum operator is going to consume. So the quorum operator is just the name for this operator, by the way. So that's going to take that YAML representation. Then it's going to do everything I need to start up a new pod or a new bank, and you know, that includes creating a service, creating the pod, starting the pod, of course, creating volumes, creating config maps and secrets, and inserting those secrets into it, so that they can just have one piece of YAML that deploys in the institution or deletes one, and again they're not dealing with the API natives. And again, the whole point of this is that you know, that this operator sits inside the cluster and is able to see they're able to query the API server and be able to find the state of the network. And again, because it's already running in the cluster, there's Kubernetes native ways around, you know, which service account it runs at, using cluster role bindings to ensure that that operator can only invoke you know, operations on a particular namespace or on a particular pod, you know, while not being a, you know, a super user and having the run of it, so to speak. And again, my concern with you know, an Ansible based approach or a Puppet or Chef based approach was, in order to support this logic where, you know, this seed node maybe has to call a function or has to be invoked with a peering function. Well, the RPC call comes from within the cluster, and I know how to lock that down in Kubernetes. Whereas if I'm doing that from outside the cluster, then I have to open a port for that, or I have to relax a rule, and that's something which I think is we don't really have to, or we really shouldn't be doing. I added a few notes again. We never got to this part, but as seems to be pretty standard these days, we used Vault for storing and for generating, in fact, secrets. So on the PKI side, you know, creating an intermediate CA from which we could generate public and private keys, so that if we had to rotate certificates, that we knew all of our nodes were belong to one particular CA. Again, was a pretty powerful concept, and something which is a baseline ask for any regulated environment I've worked in. Because we went with Helm 3, which doesn't have Teller anymore. One less thing to worry about, one less thing to secure, and especially given that I think it was the start of the year, there was a 0-day found in Helm v2 down to an issue with Teller. You know, again, somewhat of a no-brainer. And we used Flux inside the cluster itself to deploy both the operator and deploy the actual nodes themselves. So everything was GitOps driven. I've kind of illustrated the workflow here, and this is as much an overview of what operators actually do. So in the first instance, it's just sitting there doing nothing. It's observing, waiting for API events. Over in the second case here, let's say for now we're not using GitOps and it's a user. They do a kubectl apply, and inside that CRD, they've specified that quorum set object I talked about. And of course, that apply goes to the API server. And then what happens is the API server queues an event, or it goes into what's called the reconcile loop, and that ultimately invokes the custom code that we've written in the operator. So those first two steps that's what happens with Kubernetes operators regardless. There's no deviation from that, so that's boilerplate. What's custom is over here in step 3. And that really talks to the workflow as to what we need to do to create a new node and add it into the network. Now, I'm not gonna bore everyone to tears by walking through that specifically, but what you can see is that there's multiple phases of initially creating the service, using that IP address from the service to then provision the node ID, and then invoking an API that uses both that IP address and the node ID to successfully peer a new node into the network. Now, again, very easy to do with a Golang based operator or Golang or operator based approach, because you have the ability to query the API server pretty easily. You don't have to worry about hard-coded credentials or mounting credentials into the operator. It's done by virtue of the fact that you provision the operator originally with the correct cluster role binding and role binding. But as you can see, this is just for adding a node. And the amount of Ansible we wrote to support this workflow, was pretty significant. Doing this in Go actually was really quickly, and again, not being inside the cluster, being able to query the API server, having a bunch of code to go to, meant that this was actually pretty quick to do. I think where the problems start to arise is realizing the sheer number of state transitions that could happen. What happens, for example, if the operator gets deleted and we need to re-add the operator? What happens if we delete a quorum service or quorum pod? Quorum is just the name of the blockchain, by the way. How do we rebalance our network? What if we delete both a pod and an operator and bring them back up? What do I have to do to get us back to a known state? And that's where things got really painful. And that's where some of the testing we did kind of started to reveal issues which we might not otherwise have encountered on a laptop. I'm going to take another drink here, and I'll take a breath for anyone to ask questions. Okay, I'll zip through this because I know I've been talking for an hour here now. I haven't given anyone time of day. Comes as no surprise that there's SDKs to help work with Kubernetes, and that's the Operator SDK created by CoreOS. Again, there's as you'll see from the code I'll show you, it's not exactly a clean environment to work in the sense of you don't get it's not like working with a chef cookbook where you basically say, I want SSH installed in a box and ensure that it's present. 3 lines does it maybe in Chef or Puppet or Ansible, but in the case of the Operator SDK, the code, the boilerplate is there for everybody to see and poke at. And again, it's not necessary to understand all of it, but it's certainly important to at least understand what the workflow is. And it provides the main thing to point out there is, remember I talked about creating a custom API object. It provides a command line for creating and updating those API objects. So if you decide you want to add a field to your YAML, you run the command line and it auto generates all of the YAML and code changes required to get that in place. Provides a command line for compiling it and updating the CRDs. Provides a lifecycle function where all changes to an application are handled. And that's ultimately what I'm going to get to. That's the reconcile. And if you look at it this way, if all of us are writing our Puppet, Chef, or Ansible code correctly, it's idempotent. If I run it the first time, things might happen. If I run it the second time and we haven't changed any configuration, then nothing should change. And the same goes for the Operator SDK. Unless something has changed in a configuration, it really should be the reconcile function really shouldn't make any changes. I keep go. So some code. All right, let me stop. Let me just stop sharing here. Actually, all right. So what we're looking at here is some code, and the vast majority of this is boilerplate. And all of these comments are what you would find if you actually added or ran the tool. Now, there's a few things a few concepts I'm going to point out here. I promise I'm not going to spend too much time in here. I'll up the font size a little more. But first off, how do we know what objects we want to watch for? I.e., when something happens in the API server, how do I know what to look for? And you will find yourself manually creating calls like this. And that basically says is I want to watch for any change to my quorum set CRD type. And that ensures that the only time that this reconciler gets created or gets invoked is when anything happens on a quorum set object type. And that, again, I'll leave it as an exercise to anyone who's interested to go off and look at the operator SDK code. So that's the first thing to point out. A lot of the rest of this is boilerplate. It's code you don't have to write, but again, it doesn't exactly make for an easy demo to basically try and point out what's visually relevant. But back to basically what I was talking about. The first thing that the reconcile needs to do is basically find the instance or try and find the instance of the quorum set that the YAML is about. So this is a really kind of dumb fetch to actually get the existing object. And all of the logic that's further on down here is if an error occurs, for example, in trying to get the initial quorum set, it might be because the API server is a bad state. It might be restarted. Then log the error, but potentially also requeue the event. Now, why might you requeue an event? Well, let's talk about the next thing, and that's how you delete, how you handle the deletion. So again, for context, when we're in this code, an API event has occurred. Somebody's applied a piece of YAML that tries to either create or update a blockchain node in this case. But the other thing they might have done is deleted a node. And the way you kind of flag to the API server that you want to have a specific deletion handler is by using a finalizer. And this kind of threw me at the start because I expected just to be able to just have to do like if an event.type equals delete, then branch off into your logic. But again, this is one of the things I found idiomatically strange about operators. And in fact, this is the actual check. You actually check the deletion timestamp is 0 to determine if you want to proceed with the deletion. Now, what do we do when we delete? Well, inside this block is all of our application specific things. We find our seed node. The seed node is basically the master node. It's the node from which all the other nodes ultimately get peered. And because you have to start somewhere. You can't start with a zero node network. And again, this code isn't exactly efficient, but what it does is it tries to find in the peer list the peer that's being deleted, and then perform some logic to make explicit API calls to remove that node from the pool. Again, the takeaway from this really is that doing this with Ansible or stateful sets or Puppet Chef are just not possible. And that's why we had to go the route of ultimately using an operator. And again, I know it's a bit strange to start with object deletion, but if we move further on down here, you'll see the parts where we actually begin to create our pod. And again, I'm not going to go through it in a huge detail, but again, what we try and do is we're using a deployment to manage our pods. If we find it, if there's no error, then we basically go into a mode where we are creating a new pod. Back to the logic I was talking about, we need to create the service first to get the IP address, and that's just a function. If I look further on down for, you can see here, this is a Golang representation of a YAML deployment. And again, it's kind of time consuming and boring to write, but again, what's the word? Reassuringly boring is maybe a good way to put it. Find my, where is it? All right, here we go. So by this stage, we're in a loop where we can be assured that we are creating all of the objects needed to create a new node. So you can see here, for example, I create the service. I also create some config maps for storing some dynamic data in. And again, back to what I was saying before, there's a need for to understand from the permissioning point of view who your neighbors are in the actual deployment. and we do things like use a static config map, which is dynamically generated for that pod, and then finally we create the deployment, and we return. This again is idiomatic for returning a result whenever the pod's been successfully created. If it gets to here at the bottom, we've decided that nothing needs to happen, and we can skip any kind of additional processing.
So the fact that you've got your own custom resource definition there and your own operators, that mean you're storing a certain amount of state inside Kubernetes etcd instance, and did that cause you any concern on the extra amount of storage you were putting there, or the sensitivity of data you were putting there?
Not from the point of view that what we're storing there are basically the e-nodes, which are they're a concept which uniquely addresses a blockchain, which are supposed to be public anyway. So storing that in etcd was really not a concern. The big concern was what was happening originally was secrets were being stored in config maps in etcd, and of course there was nothing to stop somebody coming along and doing a kubectl get cm and reading your private key directly out of the config map. And again, that's why I think Vault is such a great tool. Vault has, I think that it didn't back when I used it before. I was using the old dynamic secrets functionality, but it does natively integrate with Kubernetes secrets now. So if you mount a secret volume, you can mount it against Vault, and you don't have to do anything funky inside your operator or your inside your YAML.
Okay.
Again, it's one of these things which is not perfect. I'm trying to tell it again. Try with a customer who's hell bent on deploying into Kubernetes. It's a good question, but Simon. And again, this is very like a customer call we did where they were like, well, are you storing secrets in etcd and then making sure that there's a coherent story? And again, I think it's one of the not evils, but complexities around Kubernetes is for this edge case, which could potentially introduce a great breach. How exactly does Kubernetes work? And again, is time understanding Kubernetes and making sure that you haven't forgot about something worthwhile versus actually solving problems for your business? I don't know. That's probably another discussion.
Yeah, we're finding more and more customers who are using Kubernetes because they have to use Kubernetes to keep developers and employees and potential candidates interested, and it's the race or the adoption seems to be driven from the wrong end.
It's true, and again, I mean, I'm not overtly I'm not being arrogant about it, but when I see job specs that say somebody needs Node.js, Vue, and Kubernetes, I'm like, what kind of job is that exactly? What kind of, again, something I'd like to get an idea for people on. I don't think any developer should be near the Kubernetes console outside of Minikube and the local machine potentially. I think for an actual running cluster, other than maybe looking at the event log or looking at logs for a pod, I don't understand the need to have, or indeed the sanity of having live access to even a production cluster. I mean, it probably goes without saying, but again, developers, while I think they want to definitely work with the latest, coolest tech, I think, again, and I will happily be proven wrong, until somebody has worked with trying to diagnose, a resource quota issue or a pod eviction issue and how that affects application state versus just applying YAML to deploy a container, then I would rather I'll listen to my own counsel until then, quite frankly. Again, context. I'm not selling this as the way everybody should be trying to build their clusters and handle state. I think that the complexity involved here, and again, this by the way is mostly Happy Path. There's lots of state in here which I'm not managing currently with this version of the operator. But as you can see, we're writing a lot of code, to achieve a relatively modest aim. And I personally, especially when you can build an equivalent infrastructure with the likes of our favorite config management tool and plain old VMs, when the business doesn't ask for it, maybe I'm just getting too old and grumpy, and maybe I'm past the point of needing shiny new things to play with. But again, it's why I had that page of assumptions. It's like, customer comes to me saying they want Kubernetes, and my first question is, really? Do you really want to use Kubernetes? Do you understand the operational cost of doing that, the complexity?
All right. I don't want to derail you right now, but there's operational complexity everywhere. I'm involved in a project right now where we appear to be writing an orchestrator to handle patch cycles that, frankly, would be easier moving the applications to Kubernetes because there's built-in lifecycle management there.
Right.
So yeah, there's complexity no matter where you look, and if there wasn't, none of us would have jobs. So maybe.
Yeah,
I'm interested in the so like the fundamental picture that sold this was comparing on-prem ownership to cloud ownership and comparing, up to the orchestration layer. So yeah. You've been speaking about this as a multi-cloud solution, and ultimately, when it gets to a certain scale, there comes a cost decision as to whether to bring it back on-prem, and the customer will pat their own back and say, well, it's Kubernetes, so we can deploy it anywhere. So let's just ring Red Hat and get OpenShift on board. And at that point, did you have to make any vendor considerations where you're like, look, this is multi-cloud, but you need to know how to run Kubernetes. And if you don't, you're going to need a vendor who can ratify our design decisions here on their own flavor, topology, et cetera, et cetera.
So again, good question, Chris. And I have a slide actually at the end just around, how you test for this with the operator. But again, that was one of the outline business requirements was, and again, that's why I think the complexity, I question whether it's worth it, because you're constantly looking at how you're designing your solution and whether you're obeying all the idioms of Kubernetes to ensure that it runs in one environment versus another. And I'll give you an example. I mean, I'm trying to think of a good example here because I did run into lots of different edge cases. I mean, there's a JKA, I think is definitely the most stable, it's definitely the most stable and easy used of the managed Kubernetes offerings. I think EKS is quickly catching up, and I don't have an opinion on AKS. All of them infinitely superior to running on-prem. But again, back to the kinds of issues that I've encountered on-prem versus managed cloud or managed versions. I think there's lots of different ways you can be tripped up, and I think the only thing I can say there is having a test matrix which addresses all the potential environments that you need to deploy to up front is an absolute must. I did all of my development in GKE and Minikube at first, but then when I got to EKS, even just things about how you handle service accounts and tied them to AWS IAM were things which you don't think about when you're developing this stuff, but which of course impact the overall picture. And like I said, from the application point of view, it doesn't change. Like this blockchain doesn't change between environments, but everything else around it does. So, I had container scanning in GKE. I didn't have it in EKS. I had Cloud Security Center in GKE. I had guard duty in AWS, but not much of an overlap in what they're, both of them solving different problems, neither of which I was particularly concerned about. I'm not sure I waffled there, Chris. I'm sorry. Did I answer your question, or do you want me to clarify something?
No, I think that's I was just interested in the driving, we were talking about the driving decision for onboarding a lot of Kubernetes grief. And if that driving decision isn't ultimately to realize the cost benefit at the far end, then there's a very good argument against doing it.
It does.
As well, go ahead.
It does, and that is one of the things that, I mean, it's popped up with several customers now. It's and again, that's why I think it's an interesting point for debate. We need to design to be multi-cloud. And to that end, the team needs to understand the specifics of each environment while fundamentally obeying the basic kind of understanding how Kubernetes works in general. But how often are you really going to change a public cloud? I liken it back to, if anyone remembers around the turn of the century, the hotness was on the software development side was to use object relational mapping tools like Hibernate to insulate yourself from the underlying database. And all of us spent a bunch of time learning how that tool worked so we could write perfectly portable code. And it wasn't until a couple of years later, somebody asked the question, well, have you ever changed your database? And the answer was no. Well, it's like, well, why are we putting all this effort into producing a portable solution when in fact that never happens? I will say this, I definitely, especially in two of the people I'm working with right now, they run both GCP and AWS. And ultimately what they do is they play the two off against each other to get, to basically reduce the cost of ownership of running their workloads. So I think it's applicable. It's applicable in this environment, Chris. I just don't think it's applicable in most environments that I hear Kubernetes been running.
Yeah, appreciated.
Again, just my opinion. Just my opinion, and based on what I've seen.
And you've spoken to the other two things, which are like, I'm curious about the separation of concerns, like around observability and things like that, and how you keep that agnostic. So like how that moves around, like different component services, changing things in and out. Like people want it all, but they're not going to get it in a 5-year time span. Yeah,
I am somebody who likes to go all, again, I'm looking for opinions here, and we're working a lot in AWS right now, and I'm going all in on AWS. Fargate, Lambda, Aurora, RDS, rather than, and I think that in a conversation with a customer where you're saying, they're saying, after a month after discussing, architecture, it's like, we're thinking about going to Azure, and of course you get that awful feeling in the pit of your stomach. But on further examination, it comes back to that aspiration, which I liken back to that, tendency to think about database portability back in the day when it just didn't matter. And it's you go all in on AWS, for example, and you've kind of snookered yourself if you want to go to Azure or GCP. But my honest experience is I've done one of these GCP to AWS. In fact, all of this stuff, or the stuff that's related to it, we moved from GCP to AWS. And to be honest, with a team of people who know the APIs, it wasn't that big. It wasn't that big an issue. I mean, you'd swap out, for example, PubSub for SQS. Well, it's like big deal. Do you understand queues and do you understand queue persistence and selectors and the like? So like, well, you're already halfway there. It's really just code at the end of the day. Now, I'm being a bit facetious, of course, but let's say this. I'm going to say this. In my experience, the cost benefit of going all in on a platform far outweighs the potential for upping sticks and moving to another platform, which again just doesn't happen. The multi-cloud thing definitely happens, but dropping one for the other, I have not seen happen.
Cheers.
In fact, I've been talking for about an hour and a half. Sorry. Let me see. Okay, I'm getting to the end now, I promise. So deploying and testing the operator. So deployment-wise, I've only a few slides to go. Operator itself, we deployed. We created a Helm chart, and we basically installed the operator on cluster creation. Now, back to one of the peculiarities which we were super careful about in the regulated environment was, do we have an operator which is able to watch all namespaces for all nodes being added? Because potentially, we may want to segment. Let's say for argument's sake, we want all US customers in one cluster or one namespace, and all of our South American customers in another namespace. Well, do we really want to give that one operator access to all namespaces, or do we adopt an approach of one operator per namespace? And again, that's a question which we haven't solved, but the paranoia in me would say that that would be pinned to a particular namespace. But going the Helm route and correctly implementing the operator, we made the namespace a parameter. The blockchain node itself, again, what that was a Helm chart which basically configured the YAML, which I'll show a sample of shortly. public creds were checked into Git, and we used GitOps and Flux to basically do a GitOps driven deployment model. Again, private creds we mounted as secrets so as they weren't in clear text, and the future state there would be to adopt Vault. Vault is such an awesome tool. I hope it's still not buggy as hell for when I go back to, and when I say buggy as hell, I think its policy engine is buggy as hell, specifically around how you do namespaces, which is an enterprise only feature, but an awesome tool, absolutely awesome tool. It makes it really easy to ensure that you can tie a service account, the same service account that you're using to deploy your operator or your blockchain nodes is the same service account that you bind to a Vault identity. So there's a really powerful InfoSec story there when you go through a security audit. For load testing, again, the whole point of this was to be able to spin up loads of nodes. Versus 4 months to get 25 nodes running in the private data center, we span up 100 nodes in about 20 minutes in GKE. I think we ran the same test in EKS, by the way, and it was something similar. And really, it was down to the application itself, and the fact it took a long time to synchronize nodes. That was the actual issue. And the one thing it did for us there was it revealed a few issues that we hadn't really accounted for. And again, it's why writing an operator is especially difficult. I think overusing things like Ansible, Puppet, et cetera, because pod eviction, as it turns out, in the first iteration of our operator, really screwed things up because IP addresses started changing, and we hadn't written any logic to rebalance the network, and also application API timeouts. And whereas I think that Ansible, for example, has the wait keyword. And all the rest have something similar. We had to implement our own back-off retry logic in the actual Go code to account for application API timeouts. And we ended up making that a parameter in the YAML. Some of the gotchas which I ran into was, first off, I mentioned earlier, API changes between major releases. I switched from 1.14 to 1.16 in GKE, and or 1.15. And I think it was the deployment API had migrated from being V1 beta to V1, and that screwed up my operator. And again, understanding the behavior of deleting the operator, especially when you're using a finalizer, was something which you will not find in a document. And again, which is something which I could summarize as if you write an operator, be super evil with it. Put your biggest and most potent QA hat on and do everything you can to break it, because what I found was, because you're offering a first-class Kubernetes experience, you can literally deploy a node via the command line. An operator at the command line will do everything that you don't want them to do if you haven't thought about it, like deleting an operator, directly deleting a pod rather than deleting the associated API object and letting the operator do it. It's just summary, nightmare headache. And I saw this on, I think I saw somewhere on Reddit. If you want to test an operator and hope to be able to run it and everything, well, have fun. The versions I tested on were 1.14, 1.1, and 1.15 for GKE and AWS. But if you're in a position like you are, like Memcache is and MySQL are, where you want to be able to provide an operator to run on everything, including upstream, then you have quite the testing headache on your hands. Let me move on. I think I'm almost done here. And again, we went the whole Flux and GitOps goodness for deployment. And I'll bring this back to what I said earlier. I think that the typical operations team I've come across is they're really good with more traditional VM based approaches, and letting their chef automate or chef server handle config drift and the likes. But when you move that into a Kubernetes cluster, of course, the complexity just ratchets up linearly, and I think we certainly spent a huge amount of time handing over what CI/CD and GitOps look like to our customer. But again, this, if you drink the Kool-Aid and if you read all the latest patterns and Medium articles about deploying the clusters, I mean, this is what we're going to get. This is kind of table stakes. Is it good? Is it, is it good? Is a subjective thing, but is this whether this is the right thing for you or your customer? I think is something you should openly talk about and openly challenge. And this ultimately is what it's all about. All of me talking for the past friggin' hour and a half is ultimately to get down to this. I want to be able to take that piece of YAML, deploy it into a cluster, and have a new customer come up in my in my network. And again, this revision of it has the node key in clear text. This was an older version of YAML, which is a big no-no. That's like you're basically passing your your Gmail password or your work password in clear text. Whereas the node itself is the public representation of that actual node. So if we were in a public Ethereum blockchain, for example, that would be how we would identify ourselves. So get really used to looking at really long hashes if you ever find yourself working in a blockchain application. And again, the operator SDK gives you the ability to add support for these fields in, and then it will forward generate the code that you need to in order to be able to support them. So it is relatively easy, but again, once you get into what you're actually doing, which is managing the state of your whole application, I think that there's a combinatorial explosion in the number of states that you have to manage, and that's, I think, where the difficulty comes in. Monitoring, logging, we got lazy and just put all our operator logging to Stackdriver initially. On the blockchain nodes themselves, we used Prometheus and Grafana. There was no Prometheus endpoint available for the blockchain binary, so I ended up creating one and mounting it as a sidecar. So it basically it did have a stats-d capability, and again, I think there's a few open source projects that do this, and now there's another one because I don't know how to search GitHub properly. But again, relatively idiomatic and straightforward. Final notes. Operators look like they're complicated from the outside looking in, and quite frankly, they are. And they're complicated because if you have an application which actually calls for an operator, then even with 4 states to manage, you're going to find yourself writing a lot of code to handle all of the error cases, the edge cases, accounting for things happening in the cluster. So you really need kind of a full-time software dev to do that, not some gap like me who happen to have a spare couple of weeks. The documentation for the operator SDK is great, and the few projects like MySQL and Memcache that have operators are actually really good. But I mean, again, even just finding out how to delete something was a bit of a freaking challenge for me until I found out what finalizers were. There are Helm and Ansible versions of the operator SDK. So while I chose to write Go, you can write the operators in Helm or Ansible, but you make certain trade-offs as a result of doing that, which you can look at the documentation and there's a guide as to how you pick one. I'd regard it as a weapon of last resort. And again, the whole run up to this has been working in a regulated environment is a pain. Operators are sufficiently complex that if you don't have an operations team or an InfoSec team that understand Kubernetes, let alone operators, you're going to have a huge handover and a huge documentation, a huge training effort in your hand. Do you really want to support a custom operator and for all of your users or all of your environments versus a playbook or a cookbook or a Puppet manifest, which is relatively well understood and which is a good community around? Well, again, I'll leave it up to you. And lastly, this is the only marketing I'll do. I am currently hiring. If I haven't scared anyone to death with the kinds of stuff that we're doing, and I'm looking for a few DevOps people to work in GCP, AWS, Kubernetes, etc. And a few software devs too. I'm not on LinkedIn anymore or any social media. I'm trying to purge myself of them. So the best way to get me is at that email address. And I've talked for an hour and a half, so I'm going to take a drink and and leave it there.
Thank you very much, Glenn. I'll fill the silence as you take your drink. That's been great. It's an area of Kubernetes that I hadn't really paid much attention to. And yeah, it's an interesting insight into what would drive you to do it and the pitfalls as to building your own operator. Yeah, very interesting. Thank you very much. Much appreciated.
Again, I think that, I don't think if had I not been a software developer, and again, had I not been a software developer in a previous life, I'm not sure I would even have attempted it.
Mm-hmm.
You know, and Go, I'll say this, Go it's an easy language to get to grips with. I think anyone that writes Go for any length of time gets bored with it, because it's like writing C without the imminent danger that makes it fun. But, you know, like I said, it's an opinionated language as well. So things like Go FMT, which let you format things, you know, there's useful frameworks around it. So I think that's something to note as well. And again, I think that you can see yourself, if you just Google for operator examples, there's not a lot of them out there. And those that there are tend to be for database style technology. And I guess you could say a blockchain is kind of in a way as a database. I have not drunk the blockchain Kool-Aid, by the way. Again, this is purely requirements of the job, but it's a like blockchain itself. Operators have a very limited set of use cases by the looks of it. Has anyone else on here actually written an operator and can basically give some perspective?
Silence. John McCabe has a question there in chat. Yeah.
I think that's validating.
John McCabe has a question there in the chat. What sort of overhead have you found supporting Kubernetes version upgrades with your custom operators?
Since I went to 1.1.5, it's been relatively gentle. So I mean, my test matrix is very small right now. It's basically EKS and GKE with version 1.1.5 and 1.1.6, and once that, and even then it was like 2 changes. It was relatively straightforward, but at KubeCon in San Diego in December, I was at the SIG for security, and I asked them if pod security policies were ever going to get out of beta, and they said, "Watch this space." And there was discussion that basically pod security policy, for example, might be abandoned altogether, and them using an OPA-based solution instead. So just the level of churn in the APIs scares the shit out of me, to be honest. You know, I wouldn't want to hang my hat on anything for any length of time right now, to be honest. KubeCon's fun, by the way, for getting access to people on the Kate's team. It's if you can justify the expense, or we could travel anywhere for that matter at the Mint. I mean, it's definitely worth making that to it. You never know who you're gonna. I ran into John Fitzpatrick standing outside KubeCon.
Yeah, that was an event.
What do you say?
I got all the way over there and didn't get to the conference and had to fly home with an emergency the next day.
I've got a stack of stickers which I'll throw your way if I ever see you in person again.
It's going to be interesting to see how the bigger conferences cope with moving online. I know a lot of the smaller conferences and the meetup space has made the transition relatively well, but the conferences that used to be thousands and tens of thousands of people, like the old OpenStack, like KubeCon now, I don't know whether you get the same access in the community type approach with something that size moving online.
The best conference I ever went to was B-Sides Las Vegas right before DEF CON, because it was that smaller, tighter knit group of people, but I don't know if that will translate into a virtual format, because the fun part was it was such a small, relatively small group. I mean, you go to DEF CON, it's freaking 22,000 people. B-Sides is like 1,000 people. And again, I think things like that have to come back in person. I don't think they work online. I hope anyway.
Yeah, so my if we're sharing favorite conferences, Configuration Management Camp every February in Ghent in Belgium has been my favorite since it started in 2014, and it's that 500 to 700 people. It breaks out into various rooms in the afternoons, and you can get up close and personal with the people working on projects in the community that you're in. And I think that has been lost in some of the bigger ones, and I don't know how the smaller ones replicate parts of that. The things that I've seen done, like Slack channels before and after conferences, I think replicates some of it, especially when they had one of the more recent conferences, they had Slack channels for each talk before and after. So you kind of had, the people that you were in the room with type approach and highly focused, relevant questions and conversations.
It's unfortunate. I mean, again, it's generally unfortunate, and I'm counting my blessings. And I'm sure we all are, that we're in the line of work that we can sit around and be functional as employees all the same.
Yep.
Give you some background to our company. We've went from, back in March, we were like 15 people, and now we're 36. Most of us haven't met each other in person. And our demeanor now is remote based. And I wonder, just getting back into an office, whether it's irreparably influenced how we interact with people. In fact, a lot of people I know are now they hated the idea of work from home, and now they're like, well, now I'm staying at home because it's so much fun. And I wonder if it would be unfortunate if things like Config Management Camp and B-Sides, suffered for it, because they're such great conferences precisely because they give you access to people that, you just wouldn't have otherwise.
Yeah.
Do you get many people from the likes of the SIGs at Config Management Camp, or is it kind of typically, chef and salt stack?
No. There's the Kubernetes and the container land space has been a sizable chunk of it in the last couple of years. So on the SIG representation, I'm not sure how many people from explicitly linked with a SIG would be there. We have people from Helm turn up. There's people from all sorts of toolkits. There was an awful lot of talks on the likes of Captain, JSonnet, Helm. There was a talk on Helm by some of the Helm contributors and the migration process from 2 to 3. So there's a sizable configuration or Kubernetes representation there. Not so sure about specific SIGs though.
Yes, I'm going to say KubeCon, both the KubeCon Europe and the US are invaluable for that. But I mean, based on everything I've just kind of talked about, I look at it more of an exercise as trying to prepare myself for what's going to change down the line, so that we're not making bad decisions.
Mm-hmm.
Yeah, predict the future, eh? Easy.
If we could do that, life would be easy.